Okay, let's start permutation. A permutation is an arrangement of items in a particular order. So order is very important. For example, if you are arranging two letters A and B, AB and BA is two order. It's not the same. I'm not combining two letters. AB is not the same as BA. For example, I have three letters here, A, B, and C. And I wanted to pick two of them, or the three of them. If I'm going to arrange the three of them, it's not ABC, because ABC is different than CBA, different than ACB. But what if I'm going to pick three letters from ABC? What is the arrangement I do have, if order is matters? A, B, C. A, C, B. What else? B, C, A. Huh? B, A, C. C, A, B. C, B, A. So from three letters, if I wanted to arrange three of them and orders is matters, it's very important the order of it. Okay? This is called permutation. So permutation generally is choosing items R from N. Choosing items R from N. Or we can say that NPR means the number of permutation of N things taken from R at one time. Okay? The rule for NPR, if you are going to use it, is N factorial divided by the difference between N and R factorial, where R is a positive number, cannot be negative number. And always N is greater than R. For example, I can't write 3P5. Why? You can't choose 5 things out of 3. For example, 5P3, it means choosing 3 items from 5. Choosing 3 items from 5. It's 5 factorial over the difference between 5 and 3, which is 2 factorial. The answer can be written as 5 factorial over 2, or can be written as 5 by 3 by 2. For example, let's go to this one, the one that we solved it. You have 3 letters, right? If you are going to choose between the 3 letters, 1 letter to put it here, how many choices do you have? 3, A or B or C. Then, if you are going to choose for a place for the second letter, you have only 2 letters left, right? So it's 3 times 2. And finally, you have only 1 letter to choose, which is 1. So 3 by 2 by 1, which is 6. So I can use one of 2 rules, the factorial of the number itself, or N factorial over N minus R. Let's go to the first example. A combination lock will open when the right choice of 3 numbers from 1 to 30 in exclusive is selected. How many different lock combinations are possible, assuming no number is repeated? Maybe for one of the students can see the word combination, said, oh, this is combination. No. If you have a secret code, if you have a password, if you have a lock key, order matters. For example, 1, 2, 3, not the same as 2, 3, 1. I'm going to choose out of how many letters? I'm going to choose how many letters? 3 numbers. From how many? So it's a 30 P3. 30 P3. And easily you can use calculator to find the 30 factorial over 27 factorial. Or you can say that I'm going to choose 3 letters or 3 numbers out of 30. At the first choices, I'm going to choose out of 30. But in the second one, I'm going to choose out of, and the third one, I'm going to choose out of 28. The answer is 30 by 29 by 28, which is equal to 24,360. Last example for today. A group of 8 swimmers are swimming in a race. So I have the word race. And I have first, second, and third places. So there is arrangement. There is order for the players who are playing this game, right? So how many different outcomes? First, it's a permutation. It's not combination because I have order and orders matters. I'm going to choose out of 3. So I can write it's 8 factorial over the difference, which is 5 factorial, or I can write it's 8 by 7 by 6, which is equal 376. You said that? Would you please calculate it? 8 by 7 by 6. 336.